Composting 101. An Introduction to Composting is a presentation by Kenneth Fall, an employee of a municipal solid waste facility since 2005. It is an attempt to cover the basic concepts of composting toward the development of a composting program at a public landfill. A sense of compost is a statement of compost philosophy. To be human is to be part of the earth. A human body's organic components make us one of the many carbon life forms that returns itself to the earth once spent and used. Life in its simplest form gives back its nutrients to the earth from where it came. We are part of nature's ongoing compost program. Composting 101 is a longer version than its companion, An Introduction to Composting. It begins with a definition of composting, proceeds to a discussion of carbon-based life forms, then to the three levels of consumers. The composting process goes on to the macro and micronutrients, the CN ratio, the high carbon materials, the high nitrogen materials, and materials to avoid. The CN ratio of various wastes is discussed and how to adjust it. A compost calculator is referenced along with a fundamental reality. The phases of aerobic composting are considered along with the PFRP, bulk density, FAS, particle size, temperature, and moisture. When is it done, of course, is also examined, as well as some concluding remarks. What is composting is answered by an engineer and an organic gardener. Louis F. Diaz, an environmental engineer, states, composting is the biological decomposition of waste consisting of organic substances of plant or animal origin under controlled conditions to a state sufficiently stable for nuisance-free storage and utilization. Jerry Minich, an organic gardener, writes, composting is, in its broadest terms, the biological reduction of organic waste to humus. Whenever a plant or animal dies, its remains are attacked by soil microorganisms and larger soil fauna, and are eventually reduced to an earth-like substance that forms a beneficial growing environment for plant roots. A comparison of the previous definitions of composting reveals both agree that composting is a biological process of decomposition or reduction. Each identifies the components as waste of organic substances, plant or animal. The engineer is satisfied with a state sufficiently stable, while the gardener's goal is humus. In the end, the engineer is looking for nuisance-free storage and utilization, while the gardener wants an earth-like substance that forms a beneficial growing environment for plant roots. Both are correct. What do we find about carbon-based life forms? Wikipedia's contributors define it thus. Carbon forms the key component for all known naturally occurring life on Earth. Carrie Oceans, a lecturer at the 2015 USCC Compost Operations Training Course at Cal Poly Pomona, stated categorically, rule of thumb, anything once alive contains carbon. This diagram is a representation by Dr. Daniel Dindal, cited by the Michigan Department of Natural Resources in the Yard Waste Composting Guide, 1989. Three levels of consumers are represented. The first level consumers feed directly on the decomposing organic residues. On the first level are the actinomycetes, the fungi, the bacteria, the earthworms, the snails, slugs, millipedes, beetle mites, and roundworms. The second level consumers feed on the first level consumers. On the second level we find the springtails, the mold mites, the feather-winged beetles, the rotifera, the protozoa, and the nematodes. Finally, the third level consumers feed on the second level consumers, and the third level consumers are the ground beetles, the pseudoscorpions, the predatory mites, rove beetles, and ants. The composting process is the combining of organic matter with oxygen and water, which produces the byproducts of heat, water, and carbon dioxide to form the final product of compost. The composting that has transpired over the ages is the same today. What works in the backyard compost pile is the same process when scaled up to the commercial level. Microbes are the key active agents in composting. The macronutrients of carbon, nitrogen, phosphorus, and potassium feed the microbes. The micronutrients, such as cobalt, manganese, magnesium, and copper, also feed the microbes. So then, composting can be viewed as simply feeding the microbes. What is the carbon to nitrogen ratio? In composting, the two most important nutrients are carbon and nitrogen. During microbial growth, approximately 25 to 30 parts of carbon are needed for every unit of nitrogen, as demonstrated by Clarence G. Golowek in a University of California study in 1953. A CN ratio of 30 is the same as a ratio of 30 to 1, which is 30 parts of carbon for every 1 part of nitrogen. This brings us back to the significance of carbon in composting. Carbon is the central element of composting, while nitrogen is the most significant other ingredient. Of the materials to compost, the browns have high carbon content. Brown is reference to the color of the organic material. This includes wood products, fruit waste, vegetable stalks, leaves, and peat moss, to name a few. The greens have high nitrogen content. Green typifies the color of this organic material, but not always. Alfalfa, algae, grass clippings, clover, hay, garden waste, vegetable scraps, seaweed, and manures are representative of this category. Manure is commonly identified with its nitrogen content, and the nitrogen is often connected with its combustible nature. Of the materials to avoid in composting, coal ash contains damaging sulfur and iron. Colored paper contains heavy metals and other toxics. Diseased plants, if not properly heated in composting, should be avoided. Inorganic materials, of course, will not compost and probably contain toxics or chemicals. Meat, bones, fish, fat, and dairy stink and attract animals. Pet droppings are potentially diseased or toxic. And synthetic chemicals from lawn, garden, herbicides, pesticides should be avoided. The nitrogen and CN of various wastes should be considered thus. A CN of 6 for activated sludge means it has 6 parts of carbon for every 1 part of nitrogen. That means that the activated sludge, if it has typically 5 parts of nitrogen, should have a corresponding 30 parts of carbon to proportionally maintain a 6:1 CN ratio. This chart is from Composting and Recycling Municipal Solid Waste. Notice the CN ratio for sawdust is 200 to 500, which means the carbon content of sawdust must be quite large compared to a tiny amount of nitrogen. Urine would have a slightly smaller carbon content compared to its nitrogen at a CN of 0.8. Adjusting the CN ratio by increasing or decreasing the carbon in relation to the nitrogen enables us to control the composting process. If the CN of the waste is too high, add nitrogen. If the CN of the waste is too low, add carbon. Too high a CN slows the process, and too low a CN leads to a nitrogen loss in the form of ammonia. A compost calculator is helpful to calculate the CN ratio. A CN of 30 to 1 means 30 scoops of carbon material is mixed with 1 scoop of nitrogen material. An online compost calculator tool is available from Green Mountain Technologies. A fundamental reality of composting was stated by Matt Cotton at the 2015 USCC Compost Operations Training course at Cal Poly Pomona. The biological principles of composting are the same regardless of scale or technology. This means that backyard composting and commercial composting are conceptually and biologically the same, though they differ in scale and in cost. The phases of aerobic composting are mesophilic, thermophilic, and curing. Mesophilic is ambient room temperature to 110 degrees Fahrenheit, which lasts a few days. Thermophilic is 110 to 170 degrees Fahrenheit, which lasts a few days to months. Curing is moderate to ambient temperatures and lasts 1 to many months. Time frames may vary, but temperatures must be achieved to complete composting. PFRP means Processes to Further Reduce Pathogens, and it is taken from Title 40 Code of Federal Regulations, Part 503, Standards for the Use or Disposal of Sewage Sludge. Why the reference to sewage sludge or biomass? Because the components of composting may contain pathogens that must be neutralized to be considered safe. Specifically, Appendix B to Part 503, Pathogen Treatment Processes reads, and notice the trio of fives. Using the windrow composting method, the temperature of the sewage sludge is maintained at 55 degrees centigrade, 131 degrees Fahrenheit, or higher for 15 days or longer. During the period when the compost is maintained at 55 degrees centigrade or higher, there should be a minimum of 5 turnings of the windrow. Bulk density measures mass per unit volume. Water is 62 pounds per cubic foot, or 1.44 tons per cubic yard. Dry topsoil is 75 pounds per cubic foot, or 1.73 tons per cubic yard. And compost is 44 pounds per cubic foot, or 1,200 pounds per cubic yard. Lower bulk density usually means greater porosity and free airspace, which means fluffy compost, and that is our goal. Free airspace in composting is important because it not only affects the speed of the composting process, but the smell that comes from the compost. Water surrounds all composts. Optimal free airspace is between 32% and 36%, as noted by Elliot Epstein in his definitive text, The Science of Composting. Odor is the most common reason that composting operations are closed down by regulators, so increasing the free airspace is crucial in making the odors go down and the complaints go away. The smaller the particle size, the more readily and rapidly the compost can be broken down. For example, wood chips compost quicker than a 2x4 length of lumber. However, exceedingly small particles the size of granulated sand will not allow airflow and would resist composting. Both mesophilic and thermophilic temperatures will be experienced during composting and should be kept about 150 degrees Fahrenheit. Too much moisture means that oxygen can't get in. Optimum moisture is 45 to 60% of the weight of the composting material. Microbes require moisture for life processes, heating and cooling, and a place to live. If moisture is less than 35%, you can't feel it on your hand. Squeezing a small handful of compost is the standard measure of moisture. If you can see the moisture, then it is at least 35%. Moisture increases while aeration decreases. When is it done? It is finished compost when it has finished curing and has reached a stable temperature. More specifically, it is done when it can grow plants. The proof of the pudding is in the eating. And of course, it is done when it has been tested through lab and facility tests. Conclusion. Composting is dynamic. What you do and how you achieve it depends on the characteristics of your end product. Only way to lower pile temperature is to lower pile height. Temperature probes help prevent fires. Moving compost from point A to point B is the only way to put out a compost fire. You may do something wrong, just fix it. Always have a plan B. Do you have a plan B? Feed the microbes and let the microbes do the composting. Philosophy of compost. Feed the soil and the soil feeds the crops. A plant grows where compost goes. The U.S. Composting Council says, compost, the sustainable solution for soil, water, plants. The U.S. Composting Council has a seal of testing assurance for those who qualify. This presentation was compiled on April 6, 2015.